This video is for Math 63, and this is for the Week 7 assignment, Dimensional Analysis, which is about measurement conversions. It's a process that people use to do multiple conversions at the same time. So I'll go through these problems and I'll do them in a couple different ways. First, I'll just make the conversions one at a time, and then I'll talk about the process of dimensional analysis where you can do them all at once. So let's start with problem 2. On the handout, since I've asked you to do all the problems in the textbook, I'll use the examples from the handout, and I'll be working from this measurement conversion sheet, which I did add. I added the currency conversions down there, which weren't on the previous week's assignment, and then I've posted that onto the website, and that'll be up there along with this video. So problem 2, we want to convert 5 gallons per hour, and we want to convert that into ounces per minute. So one thing that I'm in the habit of doing, and I encourage you to think of it this way, is that whenever you see the word per, that means divided by or over. That creates a fraction, 5 gallons per 1 hour. Okay? It's actually a rate or a ratio of 5 gallons to 1 hour. Okay, so if we want to convert this into ounces per minute, one thing that we can do is just convert the gallons into ounces and then convert the hours into minutes, and I'll do those over here on the side. So 5 gallons, and we're going to have X ounces here. Now here's the thing, we have to kind of build a conversion for ourselves out of the information. And if you can skip some of these steps, that's fine, but we've got 8 ounces in 1 cup, 2 cups in 1 pint. That means it's 16 ounces for a pint, which I think most people know. And then 2 pints equals 1 quart, so that means 32 ounces is 1 quart. And then the last part here is that 4 quarts is 1 gallon, and so if we do 4 times 32, we'll get 128 ounces to be a gallon. Okay, so we know that, let's see here, we know that 1 gallon is 128 ounces, and if we cross multiply and divide by 1, we'll get 5 times 128, which comes out to be 640. So this is 640 ounces in 1 hour, because we haven't done anything for the hour yet. Okay, and I just did a quick conversion here to get to the ounces per gallon. You can set all of these up in proportions if you want to, but just in the interest of space and time, I've just done it like this. Hopefully you can follow my reasoning there. Okay, so that says X is 640. Okay, so now we need to go back and convert the hour into, what is it, minutes. Well, that's pretty straightforward, right? 1 hour is 60 minutes. So now we've got 640 ounces in 60 minutes, and so all we have to do now is divide those two. 640 divided by 60. So this is 10.66 ounces, and you can write it like this, ounces per minute, or you can write out the word per instead of that divided by symbol. All right, so there's problem 2. Oh, now that I've done this, let me show you the process for dimensional analysis. which is related to proportions, but it works backwards, because in a proportion, you know, if I set up 5 gallons is X ounces, if we know that 1 gallon is 128 ounces. Notice across the equal sign, I put the gallons in the same place. If I'm going to do all this converting all at once, to make this conversion, I put the gallons in the opposite place and the ounces up where the gallons are there, okay? And then the same thing with the hours. 1 hour is 60 minutes. And so this one is pretty straightforward. Here's that 5 times 128 is 640. And on the bottom, 60 times 1 times 1 is 60 minutes. And that gives us that same 10.66 ounces ounces per minute. Okay? All right. So there's problem 2. 2 different ways to do that. Let's see here. Problem 4. We want to convert 120 kilometers per hour, and we want to convert that into miles per hour. So really all we have to do in problem 4 is convert the 120 kilometers. Okay? So 120 kilometers is X miles. If we know that 1.61 kilometers is 1 mile. So there's our proportion that will solve this for us. And so we do 120 times 1 divided by 1.61. And what do we get? 120 divided by 1.61 is about 74.53 miles. And that's all we really needed to know. 74.53 miles per hour. And you can write MPH there if you'd prefer. That one was relatively straightforward. We don't really need the dimensional analysis approach because we're really only making one conversion in problem 4. Okay, problem 6 is a little bit more complex. Problem 6, what are we doing? 80 miles per hour. And we want to convert that into meters per second. So we're going to have to convert both the miles and the hours. Okay, well, let's see here. 80 miles. And what we've got is a conversion from miles to kilometers. Now you can do this a couple of different ways. You know, you can convert it into meters and feet and so on. I'm going to convert the miles into kilometers. And then again, we know that 1 mile is 1.61 kilometers. So this is going to be 80 times 1.61. And that's 128.8. So X is 128.8 kilometers. And then, you know, you can make a short conversion here if you're comfortable with the metric system. It's just a process of moving that decimal point 3 places. Or we can make a proportion and say 1 kilometer is 1,000 meters. And so 128.8 kilometers is going to be, oops, that's going to be an X. And so this will be 128,800 meters. Okay. So let's see here. So we know that the 80 miles is 128,800 meters. And now we need to convert the hours into seconds. So we know that 1 hour is 60 minutes. And we know that 1 minute is 60 seconds. So again, the short version of this is to do 60 times 60. 1 hour is 3,600 seconds. Or you can say, let's see here. We know that there's 1 minute in 60 seconds. So in 60 minutes, that will be X seconds. That's another way to go about it. And there's your 60 times 60 for 3,600. So this will be 3,600 seconds. And now do that dividing. 128,800 divided by 3,600. And so our answer here is going to be 35.77 meters per second. Okay, now this one is a good one to look at the dimensional analysis approach. All right. And remember, this is set up opposite of the way that those proportions are set up. So, if we want to take this, I'll convert the miles into meters by saying, let's see, 1 mile is 1.61 kilometers. And then we know that 1 kilometer is 1,000 meters. Okay? Now notice that in the proportion you want to line them up in the same place, but when we're doing this dimensional analysis you want them in the opposite positions. Over here, 1 hour is 60 minutes, 1 minute is 60 seconds. Let's go ahead and make that more clear. Okay, so now we've got everything set up, and we just multiply across the top, and that'll give us 128,800. Multiply across the bottom, there's your 3,600, and what was our answer here? 35.77 meters per second. Okay? So if you're comfortable with this dimensional analysis approach, it can save you a little bit of time. But if you're not that comfortable with it, I would encourage you to go back and double check your work. Make sure that you're making these conversions correctly. All right, so that was problem 6. Let's see what else we've got here. Oh, problem 8, where we've got the price of gasoline. We've got 143.30 yen per liter. Okay, and we want to convert that into dollars per gallon. Okay, so again, I'll make the conversion separately, and then I'll do it using the dimensional analysis approach. So the first setup here is to change that yen into dollars. And the conversion I've got on the sheet here is that $1 is going to be, oops, there we go, 105.06 yen. And that's a conversion that I got off the internet today. If you've used a slightly different conversion, because I didn't include this until just now, that's fine. Typically, we're just going to be working off whatever conversion sheet I hand out along with the test. That's the important thing. So in any event, multiply these two, divide by this one, and so it's going to be 143.3. 143.30 divided by 105.06, and so X is going to be $1.36. I'm going to round it to an extra decimal place there. $1.364. And that's still just for a liter, though. See, we haven't converted the gallons yet. We've got to convert the 1 liter into gallons. Now, if you think about it, a liter is smaller than a gallon. So this answer is going to be smaller than 1. Okay? So let's see what we've got here. Yeah. 1 gallon off of our conversion sheet is 3.785 liters. And so if we want to convert 1 liter to gallons, there's our setup. See how I've lined up the gallons, lined up the liters on opposite sides of the equal sign. They're in the same place. And so what are we going to do? We're going to multiply 1 times 1, divide by 3.785. And so this comes out, X is going to be about 0.2642. Now remember I said how this was going to be less than 1 because gallons are bigger than liters. All right? We don't have enough liters to make a full gallon. That's why this number is less than 1. Now we need to divide. 1.364 divided by 0.2642. And so this comes out to a whopping $5.16 per gallon. Okay, so there's problem 8, done with proportions. Now we can do it using dimensional analysis. So first off, we'll convert our yen. Notice when I'm on the same side of the equal sign, these go in opposite places. All right, and this is the 105.06 for 1 gallon. For $1. And then over here, we know that 3.785 liters makes a gallon. So this will convert it for us. So we do 3.785 times 143.30 on top. That's 542.39. This will come out in dollars. On the bottom, we've got 105.06. And this is going to come out in gallons. Okay? And it's not really canceling, but a lot of people do this to remind themselves which measurements are going to be converted. The ones that don't cancel out are the ones that you end up with, the dollars and the gallons. So now we need to divide. 542.39 divided by 105.06, and there it is, $5.16 per gallon. Same answer. Whichever method you're more comfortable with, I encourage you to use that method. All right, let's keep going with these. Let's see, let's go ahead and do problem 10. How many seconds convert 1 day into seconds? And this is really just a process of multiplying, right? Because we know that there's 24 hours in 1 day and 60 minutes in 1 hour. So we need to do 24 times 60, 1,440 minutes in 24 hours, which is 1 day. And then the last thing we need to do here is multiply by 60, because there's 60 seconds in every minute, 86,400. Okay? And you can build up from the opposite way, you know, if there's 60 seconds in a minute, 60 minutes in an hour. In one of those previous problems, we said there's going to be 3,600 seconds in 1 hour. And then another way to get to the same answer is to do that 3,600 times 24 hours, 86,400. Let's see. All right, let's take a look at problem 12. Problem 12. All right, so now we want to go from 3 meters per second, and we want to change that into miles per hour. Okay, so let's see here. So first I'll do this by proportions. We'll change our meters into miles. Now 3 meters is not going to be very many miles. Okay, just to start us out. So like I was saying before, when we converted the liters into gallons, we got a fraction, right? Because it was much smaller than 1 gallon. Same thing here. This is much smaller than 1 mile. And so when we convert this, we're going to have some tiny fraction. So let's see here. 3 meters. Well, for starters, I guess I'll convert this into kilometers. We know that there's 1,000 meters in 1 kilometer. Now again, notice when I do the proportions on opposite sides of the equal sign, they have to line up. When I do that dimensional analysis over here, they go in the opposite position. So let's see, this is going to be 3 divided by 1,000, and so x is going to be 0.003 kilometers. And then we'll take our 0.003 kilometers and convert that into x miles. If we know that 1.61 kilometers is 1 mile. So here we're going to do 0.003 and divide that by 1.61. And so this comes out to be about 0.00, I'll call it 1863 miles. And I kept a bunch of numbers past the decimal point, right? Because I want to make this as accurate as possible. And once you start rounding or dropping numbers off, then you're going to lose quite a bit of accuracy. Okay? And then the seconds to hours, this is something we've calculated before, right? 60 seconds in 1 minute, 60 minutes in 1 hour. This is going to be, I'm making the reverse conversion. I was going to go to 3,600 seconds in 1 hour. If I want to convert that 1 second to an hour, again, I'm going to get this little tiny number. So let's go ahead and do that. I guess I'll need that conversion factor I was talking about. 1 second is x hours if we know that there's 3,600 seconds in 1 hour. And so this is going to be 1 divided by 3,600, another very small number. Okay? In fact, my calculator switches to scientific notation, which is actually what we'll talk about next week. So this is 0.00027 repeating hours. So these numbers aren't really all that friendly, but we can still work with them. Let's see what we get. 0.001863 divided by 0.00027 repeating. If you want to round that off to 28, that's probably not such a big deal. I just typed in a bunch of 7s. And what do we get here? I'm getting 6.7 miles per hour. Okay, so that one's a little bit tricky because, like I said, these numbers are so small, you really have to be careful with your accuracy. All right, so there's how to do it using proportions. Now let's go back and look at this using dimensional analysis. All right, so again, we want to convert the meters into kilometers, so we put the meters in the opposite position of the meters we're trying to convert. And we know that there's 1,000 meters in 1 kilometer. And then we've got to switch from kilometers to miles. So 1.61 kilometers is 1 mile. So these will cancel, we'll be left with the miles. Over here, we need to go from seconds into hours. And you can do that all at once if you use the 3,600 seconds in 1 hour, or you can use 2 conversion factors. So here's 60 times 60 times 3 on top. So I think that's going to give us 10,800. I'll double check that on the calculator. 10,800. And then on the bottom, it's 1,000 times 1.61, which is 1,610. So now we have to divide. And there it is, 6.7 miles per hour. Same thing we got using the other method. Okay, let's see here. What problem was that? That was problem 12. Let's look at problem 14. We want to convert 120 kilometers per hour, and we want to convert that into feet per second. Okay, so let's see here. To go from kilometers to feet, I'm going to use this 1 meter is 3.28 feet. So first, I'll take the kilometers, change them into meters, and again, if you're comfortable with this, it's just a matter of moving the decimal point. Okay, it's going to be 120 times 1,000. So 120,000 meters. And then we'll take that and convert it to feet. With this conversion factor, we've got 1 meter is 3.28 feet. Right. So we're going to multiply these two and divide by 1. And so we get 120,000 times 3.28. And so this is going to be 393,600 feet. Now to go from hours to seconds, we've talked about this on these previous problems. 1 hour is 3,600 seconds. And so now we divide 393,600 divided by 3,600, 109.3 repeating feet per second. All right. So there's how to do it using proportions. Now we can back up and look at doing this with dimensional analysis. It's the same process, but I'm doing it all at once. And again, notice because they're on the same side of the equal sign, they go into the opposite position. So first off, 1 kilometer is 1,000 meters. And then 1 meter is 3.28 feet. And then over here, we could just conceivably say 1 hour, 3,600 seconds, instead of breaking it up into two separate conversions. So multiply across the top, 120 times 1,000 times 3.28, which you can see these are the same calculations that we were making when we were doing those proportions. 393,600 over 3,600, and again, that comes out to be 109.3 feet per second. Same thing. All right, let's see here. Well, let's do problem 16, and then that'll be it for this assignment. Next week, like I said, we'll talk about scientific notation, and then in the last week of the term, we'll do some more of this measurement conversion, specifically addressing healthcare calculations. Let's see, so problem 16, which is more expensive? We've got 120 euros per liter, and then we want to compare that to $3.67 per gallon. So the trick is just to take one and convert it into the other units. So I'll take the euros per liter and change that into dollars per gallon. All right. So let's see, what's our conversion factor here? We know that $1 is 0.82 euros. So if we want to convert 1.20 euros, then that'll be X dollars. So we want to go 1 times 1.20 divided by 0.82. And so this comes out to be, what is it? 1,463, and I'll put that extra decimal place on there just so I don't lose any accuracy in converting. And then the liters, so we made this conversion earlier and it came out, remember how it was less than 1 gallon? So let's see here. We know that it takes 3.785 liters to make 1 gallon. So the question is, 1 liter is going to be how many gallons? And so it's going to be 1 times 1 divided by 3.785, and that gives us that same 0. I'll put it over here. So this is going to be $1.463, and this is for 0.2642 gallons. So we need to divide those two numbers, 1.463 divided by 0.2642, and that comes out to be approximately $5.54 per gallon. So this one is clearly more expensive. And that's what the question asked, which is more expensive for gasoline? 1.20 euros per liter is more expensive than $3.67 per gallon. Okay, so like I said, people sometimes get annoyed in math class when we talk about different ways to solve problems. That's just the way it is, you know, and that's not only true in mathematics, it's true in a lot of other things as well. So really your decision to make is which process makes the most sense to you. Like I said, the proportions approach sometimes takes a little bit more setting up and working through, but it's more clear what's happening, okay? That dimensional analysis process can be kind of quick, a little bit quicker because you're not making those intermediate calculations. On the other hand, sometimes people struggle to set that up correctly. So, the choice you need to make is which one makes the most sense to you, which one are you most able to do correctly to get the answers. So, as always, if you have any questions about these problems, please let me know, and then we will move on next week and start talking about scientific notation.